Welcome friends, let's take a look at some examples of factoring difference of squares. So let me just remind you of the basic pattern that you have to apply. So it's going to say x squared minus a squared. And the pattern states this is equivalent to x minus a times x plus a. For example, if you have ax, that quantity there is squared, minus b squared. So this would factor into ax minus b times ax plus b. So these are the two major rules that you have to remember usually. Now let's take a look at this in application. So imagine you have x squared minus 4. You need to factor. So first you got to rewrite the 4 as a quantity squared. So it becomes x squared minus and then 2 squared. And then you just plug into the pattern. So it becomes x minus 2 and then x plus 2. Be careful with the 2 that you see here. That's coming from this 2 right here in the base, okay? In the red 2. That's why there's a 2 here and a 2 here, and that's it. This is the answer. There's nothing you can do because x and negative 2 don't have any common factors. X and positive 2 have no other common factors. So then you go on to the next example here. Imagine, make it bigger. So x squared minus 100. Same logic. Write it first as x squared minus 10 squared. And then plug into the pattern. So it's x minus 10. And then here you're going to do x plus 10 this way. Why does the pattern work? That's for a separate video. Here we're just learning to use it. That's all. We're practicing using it. Alright, next one. Now imagine it's a little bit different. Imagine it says 4x squared and then minus 25. First of all, you should always begin by looking at the GCF, the greatest common factor. Well, 4 and 25 don't have any GCF because 4 is 2 times 2 and 25 is 5 times 5. So no GCF. There's also an x and only here, but not in this one. So try to rewrite as follows. The 4 is really 2 squared, x squared, and the 25 is really 5 squared. And now, this 2 right here in the exponent where I'm pointing, that red 2 in this position and this red 2 in this position, they can be pulled and placed outside of parentheses by the basic rules of exponents. So it becomes 2x that quantity squared minus 5 squared this way. And then you just plug into the pattern. The pattern states you're going to do 2x minus 5 times 2x plus 5. That's it. That's the expression. 2 and 5, no common factor. X is only present in one term, so that's it. This part is done. The 2 and the positive 5, again, no common factor, so it's done. That's it. These are simple as you can make them. Let's look at the next example. So now imagine we have something like 9x squared and then minus 4. Let's do it one more time. So it's going to be, in other words, 3 squared x squared minus 2 squared. The 2 in the exponent, you place that outside of parentheses. So you're going to have, therefore, 3x, that quantity squared, minus 2 squared. Then you plug into the pattern, so it's going to be 3x minus 2 and then 3x plus 2. Next example, let's make the numbers a bit bigger this time. So I'm going to say something like 16x squared and then minus 81. You want to always begin by looking at the GCF. Well, x is not part of it because only the left term has x, the right one doesn't. And then 16 is 4 times 4. 81, for example, is 9 times 9. So the 16 and 81 don't really even have any common factors either that we should pull out first. So we're going to end up here with the following, in other words. 4 squared x squared, because 4 squared is 16, minus 9 squared, because that's 81. And then this is going to become 4x minus 9 this way, and then 4x plus 9. If you like, again, if you need this intermediate step, you could write here 4x quantity squared minus 9 squared this way. You can write that step. And again, notice in this form, 4 and 9, no common factor. This 4 and positive 9, no common factor. So that's it. You stop. Let's make it a bit more abstract. So 25x squared minus y squared. Again, the only thing that you can really write here as a square is the 25. So you're going to write it at first as 5 squared x squared minus y squared. The 5 can be written now as follows. You can write 5x, that quantity squared. So pull the 2, this shared 2 right here in the exponent out. And then minus y squared, and now you plug into the pattern. The pattern states 5x minus y times 5x plus y, this way. Let's do the last level example. So I'm going to do 100x squared minus 9y squared. Now this one is a little bit different still. So we have to be right showing all the squares. So I'm going to write 10 squared at first, x squared, minus the 9, so that's 3 squared. And then y squared. You really should pause the video, right, and try to finish this on your own. This 2 in the exponent, so this red 2 and also this red 2 right here, that can be pulled outside of parentheses and placed up there. And then down below, I'm going to have 10x. So that quantity is now squared. This 2 right here, I'm going to make that one blue, and also this 2 in exponent, make that blue. That's going to give us here minus 3y, that quantity squared. So now I have a difference of two squared quantities, so you plug into the pattern. So you're going to have 10x minus 3y, and then again 10x plus 3y. And observe that 10 and 3 negative, nothing in common, x and y, nothing in common. 10 and positive 3, nothing in common, x and y, nothing in common, so you can stop, and this would be considered the answer. In other words, a fully factored form of the expression. The rule that I've used here frequently is the following. Let me remind you. When you have, for example, ab raised to the c, the exponent rule states that you can write this as a to the c times b to the c. But these rules go both ways, so if you have a to the c times b to the c, you can equivalently just write this as ab raised to the c. Accepted rule of exponents, and I use that, for example, often here. Right, when I took this part, 5 squared x squared, and I wrote it as 5x single quantity, the 2 on the outside. I took 4 squared x squared, and I wrote it as 4x as a single quantity, 2 on the outside. Likewise with the other examples. And that is it. So friends, please leave a like, please subscribe. Thank you so much for watching. I will see you in another video.